So in this video, I would like to talk to you about just a quick review of the basics of equations. So I wanted to start with a really quick review of the just basic definition. So an equation is the statement that two things are equal. And that really is all it is. You'll notice that here I provided two examples. So one example is 7 equals 7. Seems simple enough. I think we all believe that 7 is equal to 7. Another example, also fairly simple but a little bit more interesting, is x minus 5 equals 4. So, of course, the thing that makes this example a little bit more interesting is that in this case, x is a variable. And the value of it is not always the same thing, right? In fact, that is what variable means, that it has different values in different circumstances. So that brings us to the next question, or perhaps we should even call it the next definition: solving an equation. So to solve an equation means essentially, so I'm going to say here basically, this means determining when the statement of equality is true. So going back to our examples, this one here, 7 equals 7, well, if I asked you to solve that equation, that's not a silly question, but you would just say, well, this statement is always true. There isn't a set of values for which it is true and a set of other values for which it's not. 7 is a constant and it's always equal to itself. However, when we look at the other example, x minus 5 equals 4, there, if I asked you to solve that equation, you would tell me, oh, I see. So for some values of x, x minus 5 will be 4, and for other values of x, it won't be. So let's look at a little example here. Okay. So to solve the equation x minus 5 equals 4, what you're doing is you're asking, what is a value of x for which that minus 5 would be 4? So I'm sure all of you are sitting at home thinking, of course, I already know the solution. Can we just move on? But I want to kind of keep us here for a second. And I want to ask the question, is 2 a solution to this equation? Okay, because I want to sort of touch on what does it mean to ask that question? Well, again, sitting at home, tell me, what do you think? Is 2 a solution? So what that means is if I replace 2, or if I replace x with 2, will 2 minus 5 be equal to 4? And I think we can all agree that no, 2 minus 5 is negative 3, it's not 4. Well, but then what is? Okay, so let's think. What is the number that when you take 5 away from it, you get 4? So in a sense, we're reverse engineering, right? So like if you ended up with 4 after you took away 5, where did you start? So, oh, well, you must have started with 9. The solution is 9. And not only do we know that 9 is a solution, we know that 9 is the only solution because we know something about the way that subtraction works. If you take a number and you subtract another number from it, you get one value back. There's no way for another number to have 5 subtracted from it and end up with 4. So here, we really didn't need to do any kind of symbolic manipulation. We didn't need to do anything fancy to find the solution of the equation. We literally just asked the question, what value of x minus 5 would be 4? And I really encourage you guys to think of that algebra is here to help us when we cannot help ourselves. But we don't always have to rely on algebraic processes and rules and steps, because sometimes the question is just one that we can use common sense to answer. I want to try a couple other examples with you, and in doing so, we'll review some of the basic structures of how do we solve an equation where common sense alone is not quite enough for us to be able to do it easily. Okay, so here's an example. Let's try to solve the equation 2x minus 7 is equal to 3 minus 5x. Okay? So one of the things that's going to be useful later, and we're going to talk about it a lot throughout our time together, is having kind of a sense of the classification of the equation that you're looking at. So I want to take a second and I want to point out that this is a linear equation, and I'll say a little bit more about that in a few minutes. So same thing, I am asking you, what value would you put for x such that if you multiplied it by 2 and subtracted 7 on the left, you get the same thing as if you multiply by 5 and then subtract from 3 on the right. And I'm completely like willing to accept that some of you are able to do this in your head, like just kind of ballpark it, estimate it, and land on the right answer. But it's harder, right? It's not quite as easy as thinking about what number would you take away 5 from and end up with 4, like we did in the last example. So just to keep kind of this idea going, is negative 3 a solution, right? So let's see. So we have 2 times negative 3 minus 7, and we want to see if that's equal to 3 minus negative 15. So here we have negative 6 minus 7, and here we have 3 plus 15. It's not looking good, is it? So negative 6 minus 7 is negative 13, 3 plus 15 is positive 18, so this is not looking promising. So I think we can all safely agree that no, negative 3 is not a solution. Those of you who are wondering, why did she pick negative 3? No reason. I just wanted to do an example with a negative number. So then, how do we move forward? We could keep guessing. And in some situations, when maybe you came really close, it might make sense to guess a time or two more. But here, we weren't even in the ballpark, so we're going to abandon guessing. And we are going to take on a little bit more systematic approach. Now, I want to point out that in our previous example, x minus 5 equals 4, like, we could solve that equation pretty much in our head. So maybe if we aimed to get our example here to look more like the example that we just finished, maybe that would make it easier to solve. So let's work towards that goal. So goal, get all the variable terms to one side. Okay, so we have 2x minus 7 is equal to 3 minus 5x. So this is where we get to what are called properties of equality. I will write it out after I say it, but one such property, and I think that you'll all agree with me that it makes sense that this would be true, is that if you know that two things are equal to each other, and you add the same thing to both sides, to both of the things, then the resulting two quantities are still going to be equal to each other. So that's called the addition property of equality. I'll just call it the addition property. And it says that if A is equal to B, then A plus C is equal to B plus C. Now, of course, keep in mind, C here can be anything. It can be positive, it could be negative. So the addition property actually also applies to subtraction. So since my goal is to get all of the variables to one side, it's your call. You can get them to the left or to the right. I'm going to go ahead and add 5x to both sides, which is going to eliminate the x term on the right-hand side and move all of the x terms to the left. I did this because it's easier as far as pluses and minuses are concerned. If I were to move the 2x to the right, I'd have to subtract, and then I'd end up with a negative, which is just a little messier. But it's not wrong. It's just a little messier. So I have 7x minus 7 is equal to 3. So this is definitely cleaner, but you might say, you know what, there's those 7s. I still can't quite reverse engineer this in my head. So we've got all the variables to one side, but let's go further. Let's separate completely. Let's get all of the variables on one side and the constants on the other. So I'm going to achieve this by adding 7 to both sides. And I get 7x is equal to 10. And I'm actually going to go ahead up here just for the clarity of my notes. And I'm going to say here, and constants on the other. Okay, that way I kind of have my goal clearly pointed out. So at this point I'm asking, what would I multiply by 7 to get 10? Some of you might be able to figure that out, but if not, we have another property of equality to help us, which is the multiplication property. So the multiplication property of equality says, if two things are equal to each other, and we multiply both sides by the same number, then the resulting two quantities are also equal to each other, as long as C is not equal to 0. Okay, if C is equal to 0, we have a problem, and I'm not going to talk about that problem right now, but we will definitely be discussing it later. Now, just like the addition property also included subtraction, because you could add a negative number, the multiplication property also includes division, because you could multiply by a number less than 1. So here, when I have 7x is equal to 10, I'm going to go ahead and multiply both sides by 1/7, aka divide both sides by 7. So I have x is equal to 10/7. And at this point, I still have an equation. The equation is x equals to 10 over 7. But now this is an equation to which the solution is clear. What does x have to be in order for x to be 10/7? It almost sounds silly coming out. But we should always finish this by saying the solution is 10 over 7. So this is a basic review of equations, specifically what is an equation, what does it mean to solve the equation, and then a quick overview of the addition and the multiplication property. The addition and multiplication properties get us through solving linear equations. So I want to come back to that at the end of our lesson here. Linear equations are ones where we only have the variable with no exponents on it, multiplied by constants, and then adding and subtracting constants to that. So in my next video, I'm going to talk a little bit about equations that aren't linear and some techniques for solving those. You can expect a few lessons on that, but this is all I have for this time.